In today's video, we're going to continue working with the product and quotient rule. However, we're going to do some problems that look a little bit different. It's still going to be the same skills, but the setup of these problems might look a bit unusual. These are often the type of problem you're going to encounter on the AP exam. This problem starts out having some information in a table. So we have some values for a function f of 2, for the derivative of that, another function g, and the derivative of that one. So imagine that there's a function h of x, which is found by f of x times g of x. This question wants you to find the derivative of h at 2. Now your first thought might be, well, we don't really know what h of x is, or what the equations are for f of x and g of x. That really doesn't matter. This is a product rule problem. F of x and g of x are functions. We're multiplying them together to get h of x, and we want to find the derivative. So again, the product rule says the derivative of the first times the second plus the first times the derivative of the second. So let's put that in context of this problem. The derivative of the first term was my f of x. So the derivative of that would be f prime, and I'm at the point 2. So the derivative of the first times the second. So our second was g of x, in this case g of 2, plus the first, so my first term was f of 2, times the derivative of the second, so times g prime of 2. Now let's find those values from our table. Okay, so looking in my table, the first value I need is f prime of 2, which is negative 2, times g of 2, which is 6, plus f of 2, 4, times g prime of 2, which was 1. So negative 12 plus 8, plus 4. So negative 12 plus 4 is negative 8. Let's try a similar problem. But in this case, h of x is defined as f of x divided by g of x. We're trying to find the derivative at 4. We're going to use the quotient rule. Okay, so the quotient rule is on there as the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. So again, let's put this in the context of f of x and g of x. So the derivative of the top, well, the top was f of x, so the derivative of that would be f prime, and we're doing this at 4. So the derivative of the top times the bottom was g of x, so we'll want g of 4, minus the top, so f of 4, times the derivative of the bottom, so g prime of 4, all divided by the bottom squared, so g squared of 4. Substituting in our numbers, f prime of 4, the derivative of the top, was 2, times g of 4 was 3, minus the top, f of 4, was negative 5, times g prime of 4, which is 8, all over g squared of 4. So g of 4 is 3, so we're going to square that. So 3 squared. 2 times 3 is 6, minus -5 times 8. So that's going to give us a top of positive 46 all over 3 squared, or 9. And we can leave that as a fraction, 46 over 9. Let's try one more set where we have kind of a combination. So we have a function equation. So h of x equals x times cosine 3x. We also have a table with some values because we're defining a new function, n of x, as h of x plus g of x. Now when we have h of x plus g of x, that's a sum. And the derivative of a sum is the sum of the derivatives. So that h of x plus g of x, we're not going to use the product rule there. So really, when we're finding n prime of x, what we really want is h prime of x plus g prime of x. However, finding h prime of x does require a little bit of work, including the product rule. So h prime of x, our product rule says we're going to take the derivative of the first times the second. Okay, so my first term is x. The derivative of x is just 1 times the second, so that other part is going to stay the same. So 1 times cosine 3x plus the first, or u, which was x, times the derivative of the second. I'm going to head and scoot it on down so I have a little bit more room. Because to find the cosine of 3x, I am going to have to do the chain rule as well. So first, the derivative of cosine 3x. Okay, the derivative of cosine is negative sine. I'm going to keep my inside the same, so negative sine of 3x. But then I need to multiply by the derivative of the inside. The derivative of 3x is 3. Okay, so simplifying this down, my whole derivative h prime of x is cosine 3x plus, I have a negative 3x sine 3x. We want to evaluate this when x equals 5. We're going to get a numeric answer. In this problem, you do need to use your calculator. So grab your calculator. Make sure it is in radian mode. On the AP exam, unless they specifically tell you otherwise, we are going to be working in radians. So your calculator setup might be a little bit different. But what I have is cosine 3x. I'm going to evaluate this at x equals 5. So I'm going to need the cosine of 15. On my calculator, I do 15 first. I got the 15, 3 times 5. Okay. Cosine plus, scooting my calculator over so I can see the other part. So plus negative 3 times x, which was 5, times sine of 3x, that's sine of 15. So again, on my calculator, I need to go 15 sine equals negative 10.514. On the AP exam, when you have to round, when you find numbers like this on your calculator, you should always round out to 3 decimal places. Also on the AP exam, you should also show your work, even if they don't specify. Okay, now what we've done so far, remember, was we just found this part. I'm going to get us a new screen. Remember, what we were trying to do was find n prime, and that was the sum. So that was h prime of x plus g prime of x, and we're going to do that at 5. So n prime of 5 is going to equal h prime of 5 plus g prime of 5. We just did all that work on the previous page to find h prime, and that was negative 10.514. G prime is easy to find. That is on our table. So at x equals 5, g prime was negative 1. That means our final derivative is negative 11.514. Let's try one more. So again, I'm working with the same table of my g of x values. I have the same equation h of x, but this time I'm defining a function b of x as h of x times g of x. So as you can tell, I'm back to the product rule. So the product rule is going to tell me that I need to take the derivative of the first. So that would be h prime of x times the second, g of x, plus the first, h of x, times the derivative of the second, so g prime of x. The good news about this is that we found this derivative, h prime of x, on our previous page. One nice thing about the AP exam is a lot of their problems, the free response problems will have multiple sections that build off of each other. Also, if you make a mistake in a previous question, but you carry it forward in the free response, they're not going to penalize you twice. Okay, so what we're going to do is go back to our h prime of x, which we had found. So at x equals 5, our derivative of h was negative 10.514 times g of x. So here we're at the table. When x was 5, g of x was 9. Plus, now we need h of x times g prime of x. We haven't found h prime, or excuse me, we haven't found h of x yet, and it's not on the table. So I'm just going to take my equation, which was h of x equals x cosine 3x. Basically, we want to evaluate this at 5. So we're going to need 5 cosine 15. Again, remember to round your answer to 3 decimal points. So h of 5 was negative 3.798 times g prime of x. So when x equals 5, g prime was negative 1. Will give us a total for b prime of 5 of negative 98.424. As you can see, these problems are pretty in-depth and detailed. So make sure you refer back to this video as you do your next assignment.